All right, in this video, we're going to be going through some of the verifying of trig identities that we've been learning so far, the ones that we used in 5.1. To verify means that we are going to prove that one side of the expression equals the other side. In most of the cases, we will always start with the left-hand side, which is abbreviated by LHS, and we will work towards getting the right-hand side. So a couple of strategies here listed are things that we use also in Algebra 2. A lot of factoring, maybe multiplying out, FOILing out so that we can get something squared and use our Pythagorean identities, a lot of substitution. And then what we'll do is we'll learn a few new identities in the next section that we'll continue to do these same things with. You can also start with the right-hand side and work towards the left-hand side. It's usually a good idea to start with the more complicated side. In fact, I think in all the problems that we have, it's usually the left-hand side that makes the most sense to start with. So one of the things you must do, this is a must, is you must identify which side you're starting with. So since I'm starting with the left-hand side, I'm going to rewrite it, okay? You must start by writing at least one of the sides. Like I said, I'm always going to start with the left-hand side, but you have to rewrite it, okay? You can't just start by simplifying. So I'm going to start by writing the left-hand side, and then I'm going to start trying to either substitute or get things to change so that I can get it to become that right-hand side there. One of the things that we learned in section 1 is it's a good idea to write things in terms of sine and cosine. So that's what I'm going to do here to start. So I'm going to rewrite tangent as sine over cosine and cotangent as cosine over sine. Okay? And the other thing I want you to recognize in this problem is we have two terms because of that addition sign right there on the left-hand side, but on the right-hand side, there's only one term. It's the product of two different functions. So I think a good idea here is going to be to get common denominators. So in my next step, I'm going to rewrite these with a common denominator. Now, you can write the work getting there, or you can just go to what your next step would be. I'm gonna actually write the work to get there in this one because it's an example. So I'm gonna rewrite that expression, and I'm gonna write what I'm gonna do to it to get a common denominator. I'm gonna multiply this first rational expression by sine over sine, and the next one by cosine over cosine, and that's going to give me a common denominator of sine times cosine. Okay, so my numerators right now are the same in these, sine on this one, cosine in this one, but in my next step, I'm going to have that common denominator in each, sine times cosine. I'm going to just rewrite both expressions. So in our first expression here, when I multiply sine by sine, I get sine squared. And in the other expression here, I get cosine squared. And it's always a good idea to kind of, as you're working, to kind of think ahead about what might happen. As I'm writing these, right away I recognize if I combine these in the numerator, we're going to have sine squared plus cosine squared, which is equal to 1. So I'm going to come down here and rewrite this as sine squared of x plus cosine squared of x. I'm going to add those two expressions together. That means I only have one fraction here, and it has that common denominator as its denominator. Now, okay, and again, thinking ahead, if the numerator becomes 1, I'm going to have 1 over sine times cosine. Well, that's basically taking the reciprocal of that product, which is going to get me right to my final answer there. So I'm just going to take a step to write that, sine of x, cosine of x, and I'm writing everything in this example, which is, it's better to err on the side of caution. I actually think I have that written right there. Better to show more steps than you think you need to than too few. So I just separated that product right there, and now I can call that right product cosecant, that right factor, cosecant, and the left factor is secant. And then just to make it look exactly like the right-hand side, I'm going to flip those around and call it secant times cosecant of x, and I've now proven this identity. Okay, that's our main idea here, is we're proving that the left-hand side equals the right-hand side. All right, in the next one here, again, I think it's going to be a good idea to get a common denominator because we have two terms here on the left-hand side, and on the right-hand side, we only have the one term that's made up of a product of those two factors, actually three if you can call it two. So I'm going to rewrite the left-hand side. Remember, that is required. If you don't write the side that you're starting with, that's pretty much a guaranteed point off on the quiz. All right, and now I'm going to uh, multiply the right fraction by secant plus 1. I'm just going to rewrite the whole thing again, just spaced out a little bit here. And like I said, I'm going to multiply that first one by secant of x plus 1 over secant of x plus 1. This one I'm going to multiply by secant of x minus 1, secant of x minus 1 in both the numerator and denominator. All right, so what that's going to give me is this. I'm going to put everything down. I'm going to kind of skip one step here. Just put that all into one fraction right away. Now, when you multiply these binomials, notice it's the difference of squares pattern. So it's going to end up giving us secant squared minus 1. And hopefully right away that triggers your Pythagorean identities. Now, if you don't have them memorized, remember, I'm just going to real quick jot this down. We know that cosine squared plus sine squared is 1, right? And to get to the other two, we divide by either cosine squared or sine squared. Well, since I want secant squared, I'm going to divide it by, because I want to take that 1 divided by cosine to get the secant squared. So I'm going to divide the whole thing by cosine squared. So if I divide the whole thing by cosine squared, I get 1 plus tangent squared equals secant squared. Okay, or in other words, tangent squared is equal to secant squared minus 1, which coincidentally is what my denominator is. So I know I can replace that denominator with tangent squared if I need to. In the numerator, we're going to have secant of x plus 1 times 1. Well, that's just secant of x plus 1. And here I'm going to have secant of x minus 1. We don't even have to worry about doing any distributing because it was a 1 that we had there. And then we're adding those together, so I'm going to put a plus right there on addition sign. Now here's where you got to be careful. Had that been subtraction, then here, when I put that subtraction, I'd have to distribute it through there, okay? Or right away, make both of them negative. But of course, it's not subtraction, so I'm good here. I'm just going to leave it like that. And now that simplifies to secant of x. Actually, there's 2 secant of x's plus 2. Well, that's a good sign because look what we have on our right-hand side right there. Perfect. We're getting there. All right, and now we have in the denominator, I think it's going to be useful for us to change this into tangent squared. All right. Let's now look at getting that tangent squared to be written as sine squared over cosine squared. I'm just going to leave my numerator the same for right now. Oh, let me just say right now, too, at any point in time, it might be a good idea, if you're kind of looking at what this right-hand side is, and you're going, I don't think I'm going to get there. I don't know how I'm going to get there. It's not a bad idea to just start from scratch, or maybe erase the last couple steps and start over again at some point in time. You'll get there. All the identities that we give you are true identities. They can be proven. All right, so what I'm going to do now is take that numerator, and now instead of dividing by sine squared over cosine squared, I'm going to multiply by its reciprocal. Okay, little algebra 1 step here. Instead of division, multiply by the reciprocal. All right, and I'm also going to, actually in the same step, I'm going to call secant 1 over cosine. I'm going to do that in that same step right there. So I haven't changed anything. I'm also going to put this numerator, because it's 2 terms, in some sort of brackets or parentheses. Okay, so now what I'm going to do is I'm going to distribute that cosine squared over sine squared in. And I'm going to consider this 2 to be up there right now. 2 times that would just be 2 over the cosine of x. When I do that, I'm going to have 2 over, when I multiply this to this one, that cosine squared is going to cancel out with the cosine down here. Now, you don't have to show that, but just know that that's what's happening. Okay, so what I'm going to be left with is 1 cosine of x over sine squared of x is what I'm left with there. And then in the next one, I'm going to have 2 cosine squared over sine squared. And actually, I just realized I need this to be one term. So I'm going to combine these into one fraction. 2 cosine of x plus cosine squared all over sine squared. And there's other ways to get to this final answer too. You could simplify it a little bit differently, a little bit different order than I am. But this is where I'm at right now. So now what I'm going to do, I think I'm missing this 2 right here. Let's fix that. And the reason I knew that is because it looks like I got to pull that 2 out as a GCF here at some point in time. In the numerator, I could say I can pull out a 2 cosine of x. And that would leave me with 1 plus cosine of x squared. In the denominator, we have sine squared. Let's see here. All right, this is a perfect example of looking up at what we're supposed to get to and noticing I don't think I'm going to get there, and that's because I just noticed actually I made a mistake here. Right here, secant of x. This is awesome because I'm sure you guys already knew a long time ago that I screwed this up. That should be minus 1, which would mean that this plus 2 shouldn't even be there. It's going to make this a heck of a lot easier. All right, we have 2. I'm going to go all the way back to here. It happens to the best of us, and it happens to me too. I'm going to go all the way back there, and I don't know, I can delete that all with my keyboard. So I just got to do this. All right, there we go. So here I am at 2 secant of x over tangent squared. All right, this is going to be a little bit nicer now. Now 2 secant of x, I'm going to call, actually I'm going to put the 2 up in the numerator right away, 2 over the cosine of x. Tangent squared, I still want to call sine squared over cosine squared. And then I want to take that 2 over the cosine of x and then multiply it by the reciprocal cosine squared over sine squared. This makes things a heck of a lot easier because now what happens is that cosine, again, this is not something you need to show. You don't have to do that. I'm totally fine if you do. And now here we're left with 2 cosine of x over sine squared. Well, how are we going to get that then? Well, notice that this is cosine over sine, which I kind of have right there. I have sine squared, though. This is 1 over sine. So, in other words, if I separate that 2 cosine of x, if I separate this fraction into 2 cosine of x over sine of x, which would mean I need 1 over the sine of x, here, these two things are equivalent, these two statements, then the cosine over sine becomes 2 times cotangent, and the 1 over sine becomes cosecant, which is exactly what we're looking for. So that is how we verify that identity. Be careful with your Algebra 1 steps right there because it can get you. All right, our last problem here, and we may in class do another one down in the spot down there, but our last one here, we are going to use an idea. I'm going to write my left-hand side here. We're going to use an idea that we used quite a bit both in Algebra 2 and so far this year, and that is multiplying by a conjugate. Okay, so here's, it looks like I'm just rewriting it, but I'm doing that because I'm going to multiply this by something. I'm going to multiply it by the conjugate of the denominator, which is when you have a binomial and you multiply it by that same binomial with a changed sign right there. Okay, why would we ever want to do that? Well, when you multiply conjugates together, it's your a plus b, a minus b pattern, which gives you 1 minus sine squared here. Okay, it's going to give you something squared minus something squared, which is going to lead us to something with the Pythagorean identities. Because remember, the Pythagorean identities have quantities being squared in them. So 1 minus sine squared, is that, well, that's definitely related to this one. We know that 1 minus sine squared would equal cosine squared. Okay, probably don't even need to write that. You guys have that one memorized. We might be able to change it into cosine squared if it's needed. Well, it looks like it is needed because I have a cosine down there. So I'm going to go one step ahead here in the denominator and just call that cosine squared of t. Cosine of t squared. And then my numerator is 1 plus, or I'm sorry, cosine times, I'm not going to distribute this yet. Here's why I'm not going to distribute this. Because look at what the numerator is, 1 plus sine of t. That's what's going to be right here. Don't get your t here. 1 plus sine of t. Okay? Because once I cancel one of those cosines out, that one with one of those down there, I'm going to be left with my final answer here. That 1 plus the sine of t over cosine of t. So a little bit faster than the last one that we did. This one I definitely wanted to get in there because it used that idea of conjugates. We will use that because it helps us get some Pythagorean identities involved.